Okay, so this lesson will look a little bit more at simplifying algebra. Okay, so let's think about equivalent expressions, so expressions that are the same as each other. What's the same and what's different? Okay, so here we go. Here's an expression: 9 plus 9 plus 9 plus 9 plus 9. 5 times 9. 3 times 9 plus 2 times 9. 6 times 9, take away 9. Now, these are all equivalent expressions. They're expressions because they are written in this form. You've got a term plus a term plus a term, or you've got different terms here, and they're equivalent. They are the same. If you work all these out, you'll get the same answer. Which do you think is written the most simply? Just adding 5 nines up, or writing that as 5 lots of 9, or writing that out as 3 lots of 9 plus another 2 nines, or saying, well, that's 6 lots of 9 if you took 1 9 away. These are all equivalent expressions, and when we look at algebra, we'll be seeing algebraic terms written out like this as well. Okay, so for example, a plus a plus a plus a. We could group this together. We could say we've got 3a over here, we've got another 2a over here. We could say, well, that's just 5a. Or we could say that's 6a minus a. All those four expressions are equivalent. They're all equal to each other. Now, the most simplified version would be 5a. And we call this simplifying. If I gave you this expression, a plus a plus a plus a plus a, and I said, simplify that for me, I'd be asking you to write it as 5a. Okay, you're bringing all those terms together. And again, if I said, what is 3a plus 2a, you could answer that as 5a. 3 lots of something plus 2 lots of something is equal to 5 lots of that thing. And again, 6a minus a, if you've got 6 of something and you take away 1 of it, you will end up with 5 of that thing. And again, it's useful to think about representations here. So let's call the blue blocks A, and let's call the yellow blocks 1. What does Sally have? Well, she's got 1, 2, 3, 4, 5, 6, 7, 8. She's got 8A. She's also got other groupings. Sally can see that she's got 2a plus another 2a plus another 2a plus another 2a. So again, that's an equivalent expression. Let's have a look at Tom. So we can see here he's saying I've got a plus a plus a plus a, and then he's noticed that he's got 8 yellow blocks, so it's just plus 8. Okay, so again we can simplify this. 8a, and this would be 4a plus 8. And again, a little bit of extra, you can think of what value of a will make both these equal. I'll leave that for you, something to think about. So here, the student's been asked to represent 2 plus b plus 3 plus 2b. Let's just have a look at this. Here's the 2. She's used the green block to mean 3. So 2 plus b, sorry, not to mean 3, to mean b. Okay, so the green block is b. So 2 plus b, and then 3 yellow blocks represent 3 plus 2b. Okay, and again, you can see that blue is A, green is B, and that's worth 1. And she's saying, well, I can see that this is 3b plus 5. I've got 1, 2, 3, 3b plus 5. What I want you to do now is represent b plus b plus b. What would that be simplified? And I also want you to do the same for this, 3a minus a. What would 3a minus a simplify to? Okay, so hopefully we've got 3b and 2a. If you've got 3 of something and you take away 1 of it, you're left with 2. Have a go at these two as well. Okay, so hopefully you should have got 4a plus 2b plus 5. Try this one. Okay, and hopefully you should have 4a plus 3. 4a plus 3. Okay, so I thought I'd do some of these examples as well. So this first one, we've got a plus b. So what would that be? I'll do it down here where you can see a plus b. Okay, we could represent this. Let's represent a's with a square and maybe represent b with a triangle. So that would be, well, I can see I've got two squares. I've got 2a and I've got a b. Try the next one. A minus a plus b minus a plus b. Okay, let's think this through. I start off with an a. I take away a. So let's just get rid of that. I add a b. I take away another a. So let's just put a pin in that. I need to take an a away and I need to add another b. So I've got 2b and I still need to take an a away. So let's think it through. A, take away another a. I had one, I took it away, and I still need to take another one away. 2b take away a. Okay. Next one, 3c plus 4d take d. Okay, so maybe I'll use a circle to represent c. So I've got c, 3c, 4d. I might just do a line for d. 3c plus 4d, take away d. I've got 3c and 3d. Okay, and that's my simplified answer. Okay, and we're going to look at example number 4. We've got 3c plus 2c, take away 1, plus 4d, take away 2d, plus 5. And notice we can make this as complicated as we want, but it's going to work the same way. Okay, let's do it. 3c, 1, 2, 3. Add 2c, 1, 2. Okay, take away 1. Okay, so I think what we'll do with the subtract 1 is we'll leave that just now. Let's do the d's. So we've got 4d. We're going to take away 2d. And then we've got 5. Okay, now remember we had a minus 1 that we ignored. So I think now is a good time to use that minus 1. Let's take away one of these. What am I left with? I'm left with 1, 2, 3, 4, 5c plus 2d plus 4. Okay, that's my answer. Right, okay. Well, I'll leave you to answer a couple of questions, so they'll appear on screen now.